afternoon, everyone. All right, let's begin. If my voice sounds a little bit croaky, I'm still recovering from some sickness, some cold, or whatever it is. So I apologize for that. But anyway, welcome to this Inventor Basics webinar. We'll be looking at how you create your first part in Inventor 2022. So just a bit about me. My name is Daniel Payton. I'm an application engineer in the manufacturing team at Greytech in the Southampton office. If you are looking to contact me for any reason, my email address and LinkedIn address are at the bottom there. You can access this from the handout that I've sent. You'll see there's a handout in the handout section. So if you do want any of this presentation, you'll find it in there. Okay, so a bit about my background. Before I started at Greytech, I was in the industry for about 9 years, and I worked as a design engineer. I worked in the automotive industry for a number of years, where I was designing buses, and we were working on things like structural steel, sheet metal, fiberglass, plastics, glass, and a range of other products. And prior to that, I was working in the entrance control industry, where we were designing things like the spikes that come out of the ground to stop cars from going through pedestrian areas, and those blockers that also stop cars from going in. We also worked on turnstiles and speed gates and the things that you might see at train stations and those kinds of things. All right, so I've worked on a number of different products, ranging different materials as well. Having a look at Greytech, some key facts about Greytech. Greytech are over 30 years old. They are headquartered in France, and they currently operate in over 11 countries worldwide through more than 48 offices. They are a healthy, profitable, and growing company, and they continue to experience growth, and as they grow, they tend to acquire other companies so they can start to increase their product offerings and provide more services to their customers. We have more than 550 staff members, and 100 of those are located in an R&D center where they produce class-leading BIM solutions. If you don't know what BIM is basically building information modeling, and it's sort of the hot topic at the moment, especially in the architectural industry. And Greytech provide these solutions. They can come up with software. They are not only a Autodesk reseller, but they actually create and distribute their own software as well. And we want to always put our customers first. We want to make sure that our customers are always happy and satisfied with the services that we provide to them. And we can see that from the support ratings, and that's over 50,000 support cases that are logged per year, we've received a 98% excellent or good. And we also receive excellent feedback from the 3,500 plus training courses that are delivered per year. The Greytech story. So why Greytech? Greytech are unique in the way that they assist customers to tackle projects and to provide a service. They'll take a project and break it up into 4 main pillars, and each of these pillars have their own key software set to them. If we look at the Greytech Create pillar, you'll design using your Autodesk products, which can be enhanced with Greytech Power Packs. A Greytech Power Pack is basically additional functionality that's added in a tool that Autodesk might not provide to you. So it's a special tool that Greytech has made, and it just provides additional functionality that's not already present in the Autodesk software itself. If you'd like to know more about these Greytech Power Packs, then please feel free to contact your salesperson, and they'll be able to let you know how the Greytech Power Pack works and what additional tools it will provide to you. We then move to the Greytech Simulate, where you can simulate your designs for use in the real world using some of the Greytech technologies. From there, we'll take the product into the finished fabricated product and site delivery. And with all of that data that you generate, you need a good management solution And that's where GreyTech Manage comes in. All right, so this is our GreyTech Content Center. Basically, this is where we upload all of our webinars. So this webinar as well will be recorded and uploaded in about 2 weeks' time. So if you are looking for any more tips and tricks, best practices, or industry workflows, you'll find them on the GreyTech website. There's a link at the top there. You can see it just under the GreyTech Content Center. There's a link there, and you can follow that link to find more of our webinars. So we've been recording webinars for a number of years, and you'll find a huge collection of webinars, not just in the manufacturing, the MFG sector, but also in the ASC and advanced steel sectors as well. So go and have a look at all the webinars we have, and keep looking in the future as well, because we constantly add new webinars to our website. So go and have a look. There's lots of useful information there. And best of all, it's all free. All right, so to get on to what we're going to talk about today, we're going to look at how we create our first part in Inventor. All right, so we're going to go through some of the important things that you need to know when creating a part. One of the first things we're going to have a look at is regarding project files in Inventor. So I've put a little write-up here, and again, you can download the handout that you'll see in the Go to Webinar panel there. You should see a handout in there, and at least you'll have all that information. So project files are really important because they basically tell Inventor where to search for the relevant model files and also where to save those model files. So it's really important that you make sure that you have the project files set. And if you don't have any project files, you can always create your own project file. But it is worthwhile to work with the project file. If you're working with a Vault system, so if your company works with Vault, then it's a good idea to set the Vault project file to make sure that you're working in the Vault. Okay, it's one thing that you need to double check whenever you start your Inventor up, because let's say the project file is located on the network and maybe the network was down for a short amount of time while you were away from work. You come back and you've lost the link to that project file. You might end up working on your C drive by accident, and you're saving the files to the wrong place, and Inventor's searching for files in the wrong place, and it just becomes a bit of a mess. So you want to make sure that you're always working with the correct project file. Okay, but I'll show you how we can create that and how we can set it. Once we've set our project and made sure that we have the correct project file set, we can then go and create a new part. When we create a new part, we have various options for templates that we want to use. This will be our sort of starting point for our part. And it's also important to make sure that you select the correct template. You might end up selecting an imperial template, and then all of your measurements are in inches. Okay, so we'll have a look at how you can use a metric or imperial template. Or perhaps if your company has their own template, you can use that. Okay, so once we've got our project set and our template selected, we'll go and start creating our 2D sketches, either on a work plane or a solid. We'll then make sure that our sketches are fully defined with dimensions and sketch constraints. And then once we've fully defined our sketch, we'll go and create our 3D features. So we'll actually make a 3D solid out of that sketch. And then if we want to add any additional features, we'll follow the same steps again by creating a 2D sketch and creating the 3D feature. And if we want to go and alter or change any of those dimensions, we can always go back and do that. Inventor is a fully parametric program, which means that you can alter the parameters of your sketches and your solids. Okay, so let's jump into that. So here I have Inventor 2022 open. And as I said, we want to make sure that we're working with the correct project. And if we don't have a project, we need to create one. So the very first thing that we're going to do is go up to projects at the top here. This is our home screen. Go to projects. And you can see I have one called webinar first part. If I need to find a particular project that already exists, so let's say your company has a project file, and most companies do, you can then go down to the bottom and browse for it. So you use browse. You'll navigate to the correct location, wherever it is, and you'll see a project file there. It's normally a little orange looking icon, and it has the file extension IPJ, Inventor Project. And then to set it, you just simply double click on it, and that will set it. Now you can only set a new project if you have no parts or no drawings or assemblies open. So it must be once you've just sort of started Inventor up, or you have to close everything that you have open in order to change the project. You can't switch a project out if you have parts or assemblies open already. Okay, so there we've browsed for the correct project. But let's say that there is no project file to begin with. If we need to create our own project file, we'll click on New at the bottom. We have two options, either a single user project or a Vault project. The Vault project will be if you're working with a Vault system. In most cases, you won't have to create your own Vault project. That will be set up when Vault is set up. So the one that we'll focus on is the single user project. Now, don't be fooled that it says single user and you think that only a single user can use it. No, you can set this up on the network and then everyone can connect to that same project. Okay. So we'll use the single user project and click next. We can give our project a name. I'll just call it first part. I'm going to place it in the correct folder by using these dots. Where's my desktop? Create first part. And I'm just going to place it in the create first part. And then click finish. Now, Inventor will be able to read any parts or any model files that are saved in that folder or any of its subfolders. Inventor will not look at any folders above that level. Well, it doesn't want to. Okay. So inside of that folder, and I'll just bring that folder up. Okay. So here's that folder. There's my two project files. And it will only look in any of these subfolders or any of these parts that are sitting here. It won't go up onto my desktop unless it really cannot find that part. Then it will start to look through folders above it, but you don't want Inventor to start doing that. Okay, otherwise you'll start to see performance issues and then it ends up selecting the wrong part and it just becomes chaotic. So you want to make sure that you've set the project file, and then going forward, anytime you save a part, it's going to be saved into that folder. All right, we can confirm that it's ticked, so it is set. We can click OK. And now I can go and create my first part. So to create a new part, we click on New. And you'll see that we start off with templates. We can drill down through templates. You'll see there's an ENUS, so English US. And under there's some subfolders. And we want to make sure that we're working with the metric template. Of course, if you are drawing a metric, then you want to use a metric template. So we're going to go to the metric folder. And you'll see that there are several templates in here. They are categorized. You can see part, assembly, drawing. So we want to work with part, and you'll see that there's a few different part templates. I'm going to use the standard millimeter IPT, which is Inventor part. and double click on it. You'll then be presented with a blank screen. Okay, now we can follow those steps that I was talking about earlier. Once we've created our template, we will start off with a 2D sketch. So we can go up to the top and start on 2D sketch. And we'll be given some work planes to start off with. These are our origin work planes. They cannot be moved or changed in any way. These are always the work planes that are situated at the 0, 0, 0 point in the X, Y, and Z direction. Okay. Now you want to generally draw on these work planes to start off with, and you generally want to try and work around the origin point as much as you can. Okay, but we'll have a look at that going forward. So I'm going to start my sketch off on the XY plane, and you can see if I move my mouse over each plane, it highlights the name of that work plane. And the reason why I'm using the XY plane is because this usually represents the front of my part, the front face. And we generally like to have the front face as the most detailed face, and we want to usually start off with the most detailed part of our part. Okay, there's no sort of set rule on which plane you should start off on, but just typically I would start off on the front of my part. So I'll start off on the XY. Okay, and there we have the start of our part. Once you start a 2D sketch on a work plane, you'll see that it now takes us into a sketching environment. We can see that we have these two lines going vertically and horizontally. And we also have some different tools up at the top here. We have line, circle, arc, rectangle, and a few other things. Okay, so now we need something to draw. So I've got a part here that I'd like to draw up. So this is something that obviously has been detailed before, but typically you might have, say, a hand sketch with some handwritten dimensions that you've maybe measured off on a part, and you want to now create that in Inventor. Now, the great thing about Inventor is that you don't have to start putting all the sizes in from the beginning. If you've worked on anything like AutoCAD before, you'd know that you usually have to put all the sizes in as you draw. Inventor, it doesn't matter if you have the sizes or not in the beginning. You can go and draw the general shape. As long as everything is more or less in proportion, you can start drawing the general shape and then add the dimensions afterwards. Okay, this makes it a lot quicker and a lot easier to actually get a design out. So let's go and have a look at how we can draw this up. Now, there are many correct ways to create a part in Inventor. There are some wrong ways to do it, and there are some ways that will look okay when you create it, but later down the line, if you need to make any changes or any edits to that part, you might notice that you change something and the geometry doesn't kind of change the way you want it to, especially with complex parts. I've experienced this in the industry where I'd drawn something up and it all looked good and it worked well, and then the customer came back and said they want to make some changes, and then I noticed that the way that I'd drawn the part didn't really allow me to make those changes very easily. It would take me a lot longer to make the changes, and in some cases it was actually easier for me to just redraw the whole part. Okay, so there are certainly some wrong ways to do things, but you won't always know the right way when you begin. Okay, what I will say is that it's a good idea to try and break the things up into basic shapes. So if we look at the basic shapes here, I can see that the bottom looks like a rectangle, this middle bit looks like a triangle, and then at the top we have a circle. And I'll try and sort of replicate that as much as possible. So to create a rectangle, I'll start off with my rectangle tool, And again, we want to try and draw as close to the center as we can, but we can always come back and reposition it. So I'm just going to draw it off to the side, and then we'll come back and reposition it. So again, I'm going to start off without any sizes. I'm just going to draw this in. So I'm just going to draw the rectangle in. I could then draw the triangular bits, but I think I'm going to draw the circle first so that I can connect those lines to the circle. So I'm going to take a circle, and I'll just draw the circle up at the top here. And then I can take my line, and I can draw the line from there to here. I'll just connect it there, and from there to there. Okay, so we more or less have the shape. I know it's not perfect yet, but you can see that's more or less the shape. There's the rectangle at the bottom, the circle up at the top, and those two lines. Okay. Now we need to start doing a little bit of work on this. Because at the moment, if I had to try and move this, look at what would happen. Do you see? There's nothing that's really fully defined here. Nothing actually works very well. And in Inventor, it's really important to make sure that your sketch is fully defined before you start creating solid geometry from it. The reason for this is because even though Inventor lets you work with geometry that's not fully defined, it will start to cause issues in your assembly level when you start creating assemblies from your parts. All right, so you want to make sure that you always have a fully defined sketch before you move on. Now you can look at how many dimensions are still needed by having a look at the bottom right of your screen. You'll see currently mine says 9 dimensions needed. But this is actually dimensions or constraints. Now constraints in Inventor are basically little tools that set rules to your geometry. So they define rules for your geometry, whether it must be vertical, horizontal, perpendicular, tangent, whatever it is. These rules tell your geometry how they need to behave. We can see those constraints over here at the top, and we have about 12 constraints over here that basically tell your geometry how to behave. Okay, before we get to that, let's go and look at putting some dimensions in first. So we can use this dimension tool over here. I'll click on the dimension tool, and I can start dimensioning some of the geometry. So I'm going to put in a dimension at the bottom here for that line. Just place that in. So we can click on the geometry that we want to dimension, which in this case is that bottom line. We now have a dimension for that length, and I can actually type in what dimension I want. In this case, it will be 78. When we change that dimension, Inventor will try and rescale that entire sketch, keeping everything in proportion. So you can see everything enlarged according to that 78. And we can continue working with dimensions and adding additional dimensions. So I'm going to place another dimension in over here. And I have a dimension from here to the top over there. And that is 78 on my drawing. I have another dimension over here. And that is 10. So when we're dimensioning, we can either dimension just a single line, or we can dimension between two lines or 2 points, depending on how you want to define the dimension. Okay, so now we're starting to get a bit of a shape here. We've got the overall width, we've got the overall height, and we have the height of that little base piece over there. All right, and we can see that we're now down to 6 dimensions needed, as you can see over there. So we need to go and add in some more dimensions, or perhaps we need to add in some constraints. Okay, so if I just pull some of this geometry, I can see that these outer lines are still moving bizarrely. Okay, and you can see that circle doesn't really have a size either, so I need to define a size for that and a position. Okay, now on my drawing, that circle has a radius of 20, so I can go and put in a dimension over there. And you'll see if you have a full circle, it defaults to a diameter dimension. We can tell it's a diameter because there's two arrows on it, pointing to both ends of the circle. But if I want to change that, it's very easy. I just right-click, go to dimension type, change it to radius, and now I can define the radius of this circle. So I can drop that in and set that to 20, which I have on my drawing. All right, now we're down to 5 dimensions needed. So how do we work with our constraints? What do our constraints do? Well, each of these constraints has a specific task. But the first one I want to have a look at here is the vertical constraint. You can see there it looks like half arrows pointing upwards. And what the vertical constraint does is it basically tells a line that it needs to be vertical. So it needs to be perfectly vertical. Or the vertical constraint can tell 2 points to be vertically aligned to each other. So you can have 2 points that are vertically aligned with each other. Now, why might we want to use this? Well, let's say, for instance, you had a line that was nearly vertical, like that, and you realized afterwards, oh, you've drawn the line, but it's not perfectly straight. You can go over to that vertical constraint tool and click on the line, and that will now align that line. Okay. In this case, we don't have any lines that need to be vertical, but what we do want is this center point of the circle to be vertically aligned with the center point of this base. Okay, because we'd like that circle to sit in the center of that base vertically. So we can use that vertical alignment tool, click on the center of the circle, and find the center point here, which is a green dot. You'll see any midpoints or center points of lines will be a green point. We can click on it, and that circle is now sitting aligned with the center point of that base. All right. Let me just delete this. So now my circle won't be able to move left and right without that base moving with it. Whereas before, if I moved the circle left and right, the base would stay in position and that circle just moved left and right. Okay, so that's all centered now. The next thing I need to look at is these lines over here. You can see that these lines can move all over the place. And really what I want is for these lines to be tangent to that circle. I want those lines to be tangent to the circle. And luckily for us, we have a tangent constraint over here. So we just click on the tangent constraint, click on the line that we want to make tangent, and click on the circle that it should be tangent to. And there we are. Those two are now tangent. We can do the same for the opposite side. Click on the line, click on the circle, and it's now tangent. So we're down to 2 dimensions needed. So we're nearly there. You can see that we are nearly fully defined. And again, it's a good idea to always check back with the dimensions needed dialog at the bottom here. You want to make sure that that's always fully defined. Now, the ways that you can check how defined something is, if you want to see if it can still be moved around, I like to go and pull some of the lines and see what still moves. In this case, I can see anything I move moves the entire shape, which is telling me that it's more or less, or more than likely, the actual X and Y position that needs to be defined for this entire profile. So the profile looks like it's fully defined, but its position in space is not fully defined. Okay, so I want to now fix this relative to some sort of point. And the only point we really have here is this origin point over here. The origin point, which is the 0, 0, 0 point. Now I need to decide how I want to fix it to that point. Do I want to have the center of the circle on that point like that? Do I want to have the edge of the base on the point like that? Or do I want to maybe have the midpoint of the base on that point like that? Now I prefer to have the midpoint of the base on that origin point, and I'll show you why that's useful. But again, there's no right or wrong way to do this. As long as you are constraining this or fixing it to the origin point in some way, and that this is all fully defined at the bottom here, then we're happy. Okay, so how do I get this to fix itself to that point there? Now I could go and use some dimensions and try and dimension it to place it on the center point there, but an even easier way to do it is using this constraint here called the coincident constraint. This coincident constraint is useful if you want to connect 2 points to each other. If you have 2 points that need to be placed on top of each other or connected, then the coincident constraint is going to help you with that. So I can click on that coincident constraint. I can say that I want to connect it to this point here at the origin. Click on that. And what point do I want to connect? I want to connect this midpoint over here. And again, it only shows up if you hover over the line. If you move your cursor over the line, you'll see the green point. Click on it, and you'll see that object now snaps to that point. Once we've done that, you'll see that my bottom right says fully constrained, and you might also notice that the color of your geometry changes. In my case, I have my geometry set up as green or red. When it's red, it means that it's not fully defined or fully constrained. And when it goes green, it tells me that it's fully constrained or fully defined. Okay, so there we have the basics of what we want to create. Now, how do we convert this into something three-dimensional? Convert it into a solid. So the way we do this is we finish the sketch at the top here to go out of the sketch environment. Go out of the sketch environment. And then we choose what tool we want to use for creating the solid. Now there's a few tools here for creating solids, but we're going to work with the extrude tool. The extrude tool is going to allow us to take a closed region, so it must be an area that's sort of watertight or airtight, somewhere where there's no gaps or no openings. And you can see here that all of these are closed regions. There's no open areas anywhere. I can then take the extrude tool, click on it, and what the extrude tool is going to do is it's going to take one of those regions and it's just going to basically give it some length or some depth or thickness, depending on the context of your drawing, whether it's depth or length or thickness that you're trying to create there. But it's basically going to add some solid material according to that profile. Okay, so in this case, I'm going to start off with the base part of this sketch here. And if I look back at the drawing over here, I can see that the length of that should be 37. So the length of that base should be 37. So I can come in here and for my distance A, I can type in 37 and click OK. And there it creates a solid base. Now what you might notice is that the whole sketch disappears after I've created that extrusion. And that's just because Inventor usually assumes that you use one sketch for one extrusion or one sketch for one solid. And once you've done that, it turns that sketch off just to keep the part nice and neat for you. But in this case, we want to go and reuse that sketch. We want to reuse some of that geometry that we had drawn in. To get that sketch back, we'll find in our browser over here, and this browser keeps track of all of our features that we've created. Anytime that you create a solid, that's regarded as a feature. So anything that you basically create in Inventor here is regarded as a feature. So in our browser here, I can see the feature that I created, which is my extrusion. There's a little plus next to it, which I can expand. I'll see sketch 1, which is that first sketch that I created. I can right click on it and just turn the visibility back on. Okay, and there's my sketch again. All right. Now with that sketch turned on again, I can continue adding in some more features. So I can go to extrude once again. And I'm going to extrude this part of the feature. But I also want to extrude the top part. And if we look at the drawing over here, so there we've done this base part over here. We now want to do this over here and that circle, because you can see here that they are both on the same line. Okay. The distance of that extrusion is going to be 12 minus the 2 millimeters over here. Do you see that 2 millimeters is actually from this face over here going backwards? Okay. So basically we want to extrude it by 10. So for my distance here, I just set it to 10. Okay. And if you intend to extrude again, you don't want to close the extrude tool down, you can use the plus instead of clicking OK. The plus is an apply button. So if we click apply, it applies it, keeps my extrude tool open, and I can go around to the back here and click on the next piece that I want to extrude, which is just the circle. And that was going to be 2 millimeters. We saw from the drawing that there's a 2 millimeter extrusion over there, 2 millimeters that it overlaps. Okay. So I'm going to set it to 2 and click OK. And there we have the basics of our part. Now I don't need to use the sketch again for this particular part, so I'm going to go and turn the sketch off by finding it in the browser again. And this thing here, as I said, is called the browser, but if you've used other software, you maybe know it as an explorer or as a model tree, but in Inventor it's regarded as the model browser. So I just find that sketch 1, right click on it and turn the visibility off. We can compare the two so far. There we are. So we've got the basic shape of it. Okay, we now need to add in some additional things here. So perhaps I want to add in the hole that goes in over there. So to add in that hole, we can either create another sketch and draw in a circle, and we can extrude that circle, because the extrude tool can either be used to add material like we've done so far, or the extrude tool can be used to remove material, which we haven't done any material removal yet. However, when we're working with holes, I would say it's usually better to use the dedicated hole tool in Inventor to create holes. Okay, it makes it a little bit easier for changing later on. And it's also going to create a feature in the browser here called hole, which is going to be a lot easier to find when you want to make changes later on. Okay, and you really want to make sure that your part is laid out in an easy to understand way, so that if you or anyone else needs to go back and edit it at a later stage, it's easy to edit and it's easy to find where those features are that you want to edit. There's nothing worse than taking someone's part and having to edit it, and they've made a big mess on that part. They've maybe created hundreds of features where they didn't need 100 features, and they've created an extrusion for absolutely everything, even for holes. And when you try and find where the hole feature is to edit it, you have to go through, 20 or 30 different features just to find where that hole is. Okay. So always keep in mind that you want to try and make it as easy and as simple to find. So we're going to use the hole command. I want to place the hole on this face over here, so I'm going to click on that face. Okay. Oh, let me just set this to no preset. So there, it starts off with the hole. Because we're working with some circular geometry, I can click on the circular reference to position the hole in the center of that. So I can click on that outer geometry there. That repositions the center of that hole. And then I can go and choose what type of hole I want and what type of seat I want. So in this case, it's just a plain drilled hole that goes through. So I'm just going to use the first options here. And I'm just going to set the diameter over here at the bottom. That diameter is 20, so I'm going to type in 20. And there we have our 20 diameter hole. Click OK. Now the next thing that might be a little bit challenging is this rib over here, this gusset type thing that they've put in on the bracket over here. And that's drawn somewhere in the center. So how do we go and draw something in the center? Well, whenever we want to create additional sketches or additional features, we either create a sketch on a work plane or on a face. But in this case, we can't use one of the faces because these faces are on the outside and that rib needs to be on the center there. Okay, so we can create our own work planes over here. But if you remember, we went and positioned our sketches on the origin point. Remember how we centered it on the origin? Just to show you again, we centered it on the origin point there. And that origin point actually has a work plane running through it. So I can go and use that work plane from the origin to draw on. So to find my origin work planes, I'll go to the origin folder here. You'll see there the YZ plane is the one that runs through the center there. So I can go and create a sketch on that YZ work plane. So I can go to start 2D sketch. And it's going to create the 2D sketch on my YZ plane. And I can now draw in that gusset profile there. So I can go and just draw this in over here. Goes to there and up to there. Okay, I've made a little bit of a mistake there. The lines didn't join up quite as well as I wanted them to, but that's okay. I can just use my constraints. Has it joined it up? Oh, it has joined it up. Let's just see, is it straight? I think it has drawn it straight. I think it was just the angle that I was working at. Okay, so now we've drawn in our gusset. We can finish the sketch. Just finish that sketch. And we can go and create our extrusion. So I can go to extrude. If there's only one closed profile in your model, Inventor will automatically pick it up. So it just makes it a little bit quicker for you. But as you saw before, where we had more than one profile, we had to select it manually. So there it selects it for us. And I have a size on my model of 15 millimeters. So I can put in the size of 15. But now that's going off to one side. So if I want to center that profile, if I want to center that extrusion, we have some options here for the direction of that extrusion. If I go that way, you see it goes the opposite way. Or I can use this third option, which places it in the center. So it centers my extrusion. So I'm happy with that. And I can click OK. All right. Now what you might have noticed is that I didn't put any dimensions on when I created that. And I said it's very important that we always have our sketches fully defined. So what if we've made this mistake and we want to go back in and edit it? That's very easy to do. Because it was the sketch that needs to be fully defined, we need to go and find that sketch again. And I showed you before how we find the sketch. We go to the extrusion that we used for that sketch, with the sketch we used for the extrusion. Click on the little plus and you'll find the sketch under that extrusion. I can double click on that sketch to edit it. So if you ever want to go back into a sketch, you just double click on it. And basically anything you want to edit in Inventor, you can edit by double clicking. You can see it says 2 dimensions needed. So I want to get rid of those 2 dimensions. And I'm just going to use the dimensions that I have on my drawing here. So there I have a 7 millimeter offset from the side. And I have a 42 millimeter dimension from the bottom of that base up to that fillet over there. So I'm going to put those 2 in. So dimension, I have 7 over here. Put in 7. And I have 42 from the bottom to that point. Go this way, 42. So there's the 7 and the 42. And you can see once I've put those 2 in, I'm fully constrained. Finish that sketch, and that repositions it. Okay. Now, if you need to go back and change anything on this model, as I said, Inventor is fully parametric, so you can change any of your dimensions. All you do is find the sketches and double click on them. So if I wanted to change the size to 85, I could put in 85 over here. If I wanted this to be 100, I could double click on that dimension, put in 100, press enter. So again, anything you want to edit, just double click on it. And you can see that updates everything. Okay, I'm just going to undo it. Now, what about if you want to edit something like the actual extrusion length? So we've only edited the sketches so far. Well, if you want to go back and edit, say, your extrusion length, or let's say we want to edit this hole size, we just find that particular feature and double click on it. So in the browser again, like the hole 1 over here, for instance, I want to double click on that. That will open up that panel again, and I can go and change the size. Let's say 24. Okay. And the last thing we want to add, let me just undo that change. The last thing we want to add here is some fillets just to clean up the edges. You can see that they've added in some little fillets over here just to clean up all the edges. And fillets we always want to add in at the very end of our model. There's many reasons why we want to do this, but it's usually if we want to make changes to the model later on, it's easier to do it without the fillets. And also, if you ever want to do any sort of FEA or stress simulation, you generally don't want to have the fillets included in on those simulations. So we normally add them in right at the end. So I can use the fillet tool over here. And I can see that most of the fillets are 1. So I can put in 1 millimeter. And we just click on the edges that we want to fillet. So these here are all 1. And then there's some that are 2. So I'll put in those fillets there that are 2. Okay. And then the last thing we want to add in, there were some holes over here. So I can drop those in using the hole command. And these holes have a little recess in them, so they are counterbore holes. So I can choose the counterbore option. I can put in the 2 counterbore holes over there. I can just put their centers in. And these have, and we can just work with the little image here again to choose the sizes. So the size here was a 10 millimeter hole with 18 at the top, and it was too deep. Okay, so that puts those holes in. Now these holes are not positioned, and we didn't create any sketch for them. But the hole command is clever and creates its own sketch in the background when you use it. So if we want to find that sketch that it's created, again, we look for the drop down, little plus next to hole. Find that sketch, double click on it, and we can go and edit it. And in this case, it has some dimensions here from the side, so I can use the dimension tool for it. And it's 12 by 12. And the same on this side. Finish the sketch, and that repositions the holes. Okay. And that's basically the real basics of how you create your first part in Inventor. So again, we will go and make sure our project file is set. We'll then choose our correct template to make sure we're drawing in the right part file. We then create a 2D sketch on one of the work planes. And again, I said I prefer the XY plane because that's the front face. We'll then go and create all of our sketches that we need, all the lines and rectangles and things that we want. And then we'll go and define them with dimensions or constraints or both, making sure that it's all fully defined. We then finish the sketch and we use whichever 3D tool we need to use. In this case, we used extrude, just to extrude some geometry. And then we can always go back and add additional sketches in or create additional extrusions, or we can go and edit those sizes if we need to manipulate this object. Okay, and those are the basics of how we create our first part. All right, so let's leave it there because of time. Let me just bring this back up. And I'll open the floor to any questions. So if you do have any questions about what we covered here, then please feel free to type them in the questions section. If you don't have any questions, thank you very much for spending time with us today and watching. If you do want to watch this again at a later stage, remember it is added onto the GreyTech website. but give it about 2 weeks for them to upload the video to the website. Okay, so thank you, everyone. Again, if you do have any questions, then just pop them into the questions section. Okay, doesn't look like there's any questions, so we'll leave it there. Again, thank you very much for watching, and I hope that you have a good day further. Thank you. Bye-bye.